Now, before that we actually find that interval, we need to talk about sampling error. So whenever you're dealing with data and not the whole population, you're always going to have a chance of being wrong. So a matter of how much you can be wrong is determined by what we call sampling error. So the sampling error is the difference between what actually happened in the sample by subtracting the actual population mean. So this is the sample mean minus the population mean. That is what we call sampling error. Okay? We have something called margin of error. We use the capital letter E for margin of error, sometimes called the maximum error or error tolerance. And that is the greatest possible distance that we could have between where we think our point estimate is, where we think our mean is, and the value of the error. Okay, and the error is found by taking the critical value, which we're going to call Z critical, times the standard deviation of the sample, which is found by taking the Z critical value times the standard deviation divided by the square root of n. And that's what we call the margin of error. How much we can be off by, either above or below the actual mean. Okay, so there are some conditions that we have to satisfy in order to use this formula. The sample needs to be random, and it needs to be normally distributed, or the quantity of the sample has to be greater than or equal to 30 in order to use this. So let's use that data from the data that we put into our calculator, where remember we found that this data, when we used this data before, we found that the x bar was equal to, what was it, 21.1? We already knew that because we calculated that for our previous example. Now, they're telling us that the standard deviation is 2.3 hours. We want a 95% confidence level. That's how confident we need to be. So C equals 95% or 0.95. Let's check our conditions and make sure that we can do this. We know from the previous example that they told us it was random. And n is equal to 40, which is greater than or equal to 30. So it satisfies both conditions. Okay, so the conditions are met. So that means that we're going to figure out, we want to have 95% confidence that it's within this range. So we need to find negative C and positive C. We need to figure out where they're at. We know that the tails come from 1/2 of 1 minus 0.95, which means 1/2 of 0.05 which is 0.025. So this is 0.025 and this is 0.025. So if I want to find that z critical number, I have to do inverse norm of 0.025, and what that's going to give me is 1.959963986, which we're going to shorten to 1.96. Now, those critical numbers are both on the left side and the right side, so I'm going to make that a plus or minus 1.96. That's my z critical number. Okay? From there, I'm going to find my margin of error, which is my E. My E is going to be my critical number times my standard deviation divided by the square root of n, which is going to be plus or minus 1.96 times my standard deviation, which is 2.3, divided by the square root of n, which is 40. Plugging that into my calculator, I'm going to get plus or minus 0.713. Okay, so all of that was so that we could make this statement. We are 95% confident, because that was the confidence level they asked us to find, that the margin of error, how much we can be off by either above or below the actual number for the population mean is plus or minus 70 or 0.713 hours.